Planning is a formal step that's necessary prior to actually making an application. You need to understand the importance of selecting the appropriate pesticide and adjuvant. There may be several products available from which to choose. Then, have standard operating procedures in place for safe tank mixing and loading procedures, and take the appropriate environmental precautions. You need to understand how to make a proper, effective pesticide application, and then finally, how to safely rinse containers and equipment, and either safely recycle or dispose of containers or waste pesticide. This module will help you understand these basic principles for pesticide application. Before any pesticide selection and application takes place, there are a few things you need to know. What is the pest? In order to successfully manage a pest, you need to know what you're dealing with. Just like a mechanic can't fix your car without knowing what's wrong, or a doctor can't help you feel better without knowing what's wrong, you can't manage your pest without knowing exactly what it is. Make sure you understand all federal, state, and local pesticide regulations. Remember, not all of the restrictions you must comply with can be found on the federal pesticide label, and it's extremely important to stay up to date on regulations. For example, some states have restrictions on the use of certain herbicides due to drift concerns. There's a risk with almost everything we do, and a pesticide application is no exception. You can reduce the potential hazard of a pesticide application by making sure you know how to properly use the application equipment. Most people wouldn't jump into a Formula One race car without having instructions on how to drive these fast vehicles. Take the same precautions before using pesticide application equipment. And finally, a statement you've heard 100 times. Read the label before selecting and applying a pesticide. The label has important information that you need to understand and follow to make a quality pesticide application. Plus, the pesticide label is the law. Okay, so the pest has been identified, and you've decided that the best management option at the time is a pesticide application. So which product are you going to use? Look and read all the labels, and remember, the crop or site of the application must be on the label, but the specific pest does not. I'm going to repeat that. The crop or site of application must be on the label for the application to be legal. In agriculture, the label is very specific as to crop, like this label states artichokes and asparagus, while in non-crop industrial sites, they include several rights-of-way, tank farms, lumber yards, and storage yards. You could expand that list to other industrial or non-crop sites that are not actually listed. The reason agricultural uses are very specific is due to the tolerances. If the ag site is not listed, the pesticide may not have a tolerance set, and food safety becomes a concern. This multi-use insecticide can be used on several sites. For ornamental plantings, it states on ornamentals without specifying particular ornamentals, so it can be used on any ornamental, with the exception of the 3 different types of ferns listed, and it may cause injury to Crassula. This insecticide is labeled for both adult and larval mosquito control. Be certain to read all parts of the label. For mosquito adults in backyards, it can be applied to ornamental shrubbery and lawn, but it has precautions about food and feed crops and concerns for using oils on ornamental plants. It can also be applied to standing water to control mosquito larvae, but again has important precautions about fish and shellfish-bearing waters. Finally, this insecticide can be used to clean up grain storage equipment before filling the storage bin, elevator, or silo with barley, corn, oats, rye, or wheat. Remember, the crop or site must be on the label. However, the pest does not have to be listed. When selecting a product, pay attention to both environmental and personal safety precautions and specific prohibitions that are stated on the label. Remember that products with the same active ingredient can be formulated in different ways for particular applications and to reduce human health hazard. Read and compare labels, then make sure you get the best product for your situation. Products may recommend adjuvants, those additives that you mix into the tank with the product to aid performance of the product. There are a variety of adjuvants available to add to your spray mixture. Buffers alter the acidity or alkalinity of the mixed water. They change the pH. Surfactants aid with deposition and coverage. Colorants let you know what you've covered, and the list of adjuvants goes on. The label may recommend an adjuvant, not reference adjuvants, or warn against the use of adjuvants. The effectiveness of some adjuvants depend on the product formulation. This sample label language states, you may want to consider an adjuvant, but also warns that they can increase the activity which may end up harming the crop. You would want to do some research on the negative effects on your crop or site prior to using a surfactant. Read the label. It really is that easy. Okay, you've selected a product. So when's the best time to apply to gain maximum benefit? Timing is usually based on the growth stage of the pest or the crop or site plants. Insects and weeds are generally easier to control when they're immature and small in size. Remember, dose make the poison. This example notes that you're more likely to gain adequate control from applications made during their active larva feeding stages. Soil condition may also be a key for timing applications. And this example notes that soil moisture is important to effective residual weed control. Applications made during times with dry soil would be a waste of money. Remember, just about any pest is easier to manage when it's young, so timing your applications to the most susceptible pest stages gives you the advantage. Don't forget about the weather. What does the label state about timing of rain or irrigation? Products differ in their rain fastness. Does the label state anything about optimal application conditions, such as temperature and cloud cover? For example, to achieve weed control, weeds must be actively growing, so if weather conditions cause the weed to shut down, you won't get weed control. How fast is the wind blowing, and in what direction? Is the wind blowing towards susceptible sites? If off-target drift were to occur, what could be impacted? Some labels, or even local and state governments, have mandatory setbacks and no-spray buffers around sensitive sites. The pesticide label only details the federal regulations, not state or local restrictions. Keep up to date on your local and state regulations, which are not always listed on the pesticide label. Pesticide labels have tons of important information, including specifics about equipment. Remember from the law chapter that any method of application can be used, with the exception of chemigation. But if a label prohibits a method, you cannot use that method. Some labels state how much spray volume is required. This is based on needs for coverage to control the pest or to reduce drift potential. No matter what the minimum gallons per acre, you need to make sure that your equipment is in proper working order. Is the tank large enough to handle the job? What type of material is the tank made of, and will it react with the pesticide being applied? What type of nozzle are you using, and are they appropriate for the formulation? Will the nozzle provide adequate coverage or provide for minimizing drift? Are they all in working order and delivering the correct volume? Are the nozzles correctly set at the proper height and spacing to give an even pattern? Are they aligned to spray past each other and not spray into each other? Does your pressure gauge accurately measure pressure? Is the pressure set in an appropriate range for the nozzle to perform? These are all extremely important questions that you need to address before each pesticide application. Before beginning an application, keep in mind any post-application restrictions. Posting may be required by the label or by state and local governments. Posting is commonly required in agriculture, ornamentals, schools, and public areas. To reduce the possibility of a pesticide exposure after the application, make sure the restricted entry interval, REI, is followed. Remember, the REI is the time period following an application when unprotected people are not allowed in the treatment area. And guess where you find this information? The pesticide label. If there's no REI stated on the label, the minimum legal REI is, quote, until sprays have dried or dusts have settled, unquote. There's a re-entry prohibition of 4 hours that is not listed on the label, but in the Agricultural Worker Protection Standard, WPS, even if you were to wear PPE. Post-application restrictions are there to protect humans, domestic animals, and livestock. For products applied to water, watch for restrictions for swimming, fishing, and drinking water. Because some of the pesticides we apply to soil for long-term control, labels may state warnings about planting transplants or rotational crops. Other products list grazing and milking restrictions. Don't forget about the pre-harvest or pre-slaughter interval. This is the number of days that must pass between the last application and the time of harvest or slaughter. By following the pre-harvest and pre-slaughter interval and all other label directions, residues should not exceed the pesticide tolerance. Everything on the label has a purpose and must be followed. No one likes to do a job twice, and tank mixing pesticides can save time and reduce labor and equipment costs. However, before you mix up a large tank mix, keep in mind that not all pesticides are compatible. There are 4 different classifications of pesticide incompatibility. The first is timing incompatibility. Mixing a pre-emergent pesticide with a post-emergent pesticide is an example of timing incompatibility. Since both herbicides are effective at different plant life stages, this mixture would be incompatible. Sometimes 2 pesticides require a different placement method, and this would lead to placement incompatibility. For example, tank mixing a soil-incorporated pesticide with another product that is effective only when applied to foliage would result in placement incompatibility. Sometimes when you mix pesticides together, they don't physically mix well. We call this physical incompatibility. It's like getting clumpy gravy when adding flour to chicken broth. The mix might form a putty or paste, separate into layers, or form a yogurt or cottage cheese-like consistency. Some physical incompatibility problems can be avoided by following proper mixing techniques and providing adequate agitation. To prevent this problem, always mix powder, flowable, and water-dispersible granule formulations into the mixed water before adding any oil-based emulsifiable concentrate. Can you imagine adding oil into your water prior to mixing up some hot chocolate? You need to get the hot chocolate particles suspended in the water prior to mixing in any oil. And no matter what you do, not all products are compatible. ECs are not compatible with fertilizers. Sometimes the problem may not be the products, but the water you're using to dilute them. Check the pH of the water. Some products are very sensitive to pH of water and require buffers be used to alter the pH before adding the pesticide. Mixing pesticides may result in a chemical change occurring in one or more of the pesticides. We call this chemical incompatibility. This affects the chemical activity of the pesticide and results in the application of a pesticide mixture that is chemically different than each pesticide applied separately. A reduced chemical activity of one or more of the pesticides in the mixture is more likely to occur when hard water, chlorinated water, or fertilizer is used as the carrier. At other times, the combination of the pesticides may result in increased chemical activity and increased effectiveness of the products. Each pesticide label details specifics regarding pesticide mixtures, if they're known. Tank mixes that are known to work as well as those that are known to be incompatible are listed. It's your responsibility to read and follow the label directions, and if the label doesn't say anything specific about a tank mix, then it's your responsibility to test for compatibility. So, how do you avoid pesticide incompatibility? First, read the pesticide labels. Next, put on the personal protective equipment stated on the label, because after all, you're going to conduct a jar test for a small-scale tank mix. Fill the jar half full with water or other carrier. Add the products one at a time in the proper order and in the proper amount. Remember, add powders before any ECs. Mix or shake the jar and observe what happens. Let the jar sit for 10 to 15 minutes and then check the mixture. If the jar is giving off heat, or the mixture looks like cottage cheese, or the products have separated into layers, then these particular products are incompatible. Just think what a mess this would have been to clean up if you'd mixed a tank load instead of a small jar. If nothing happens and it looks like the mixture will work, check it for performance and phytotoxicity. If no problems, go for it and mix your tank and off you go. Because mixing order is so important for a tank mix, let's go over the proper order again. First, add the carrier, which is usually water, but can be fertilizer. Second, add a compatibility agent if needed. Read the label for this information. Third, add any suspension products. First, the dry suspensions, such as wettable powders, dry flowables, water dispersible granules, and flowables. Then, the liquid suspensions, like flowables, liquids, and microencapsulated formulations. Fourth, add soluble liquid or soluble powder products, or products that truly dissolve in the carrier. Fifth, add any adjuvant. Again, read the label for recommendations. Finally, sixth, add any emulsion products, such as emulsifiable concentrates. The oil-based products always go in last. Although you might be trying a tank mix to save yourself time, don't be in a rush when you're mixing. Take the time to do a pre-slurry for each product before adding it to the tank. A pre-slurry is mixing a little bit of carrier with the product and obtaining a good mixture. No matter what the tank mix is, agitate the mix initially to get everything well mixed. Then during the application, certain products require continuous tank agitation to keep the suspensions from settling or the emulsions from separating. Since mixing and loading is perhaps the most hazardous pesticide handling activity, make sure you do it in an appropriate area. Many places have designated mix-load sites. Mix-load sites should be outdoors and well ventilated. Remember to always keep the mix-load area away from people and animals. For the majority of pesticide applications, the carrier used is water. Don't forget about protecting our water sources when mixing and loading. Take a look around you when you're mixing and loading to see if there's any nearby water source that may be affected by your activities. Look for drains, canals, creeks, and ponds. If possible, install a containment pad at a designated mix-load site. They allow for easy cleanup if there's a spill and help protect nearby surface or groundwater. Consider a portable mix-load pad if you mix in any different locations. Also, prevent back siphoning into a water source by creating an air gap or installing check valves or anti-siphon devices. This is especially important with any chemigation application. Protect yourself when mixing and loading by wearing the appropriate PPE. The pesticide label states what is required for the activity, but you can always wear more protection. Make sure it's clean and properly functioning. The equipment you use to measure pesticides or open pesticide containers should only be used with pesticides. Clearly mark all measuring devices. A big black marker works well. Make sure no one misuses the measuring devices. Store them in the pesticide storage area. This greatly reduces the possibility of a pesticide measuring cup being used to make Kool-Aid. Use care when opening containers so as not to spill anything or allow powders to become airborne. For powders, use a pair of scissors to gently open the container. and take the time to close every container when you're not using it. This reduces the possibility of an accidental pesticide spill. Precise measurement of pesticides when mixing and loading is extremely important. Make sure your scale or measuring device is accurate so that you're confident about the application rate. Help reduce potential exposures when mixing and loading by staying upwind of the vapors and dusts. Use extreme care to avoid splashing or spilling the concentrate product. And always measure and pour liquids below eye level to prevent eye exposures. And never leave a full or partially full sprayer unattended. People, kids, and animals are curious, and you never know who's around. What do you do with an empty pesticide container? There are two different types of containers, those you can rinse and those you can't. Let's first address cleaning and disposing of rinsable containers. First, the container must be rinsed. Legally, it must be triple rinsed to be considered a non-hazardous waste. Do this immediately upon emptying the container. So do this when you're making up your tank mix and use the container rinse water in that tank batch. If you wait until later to clean the container, you may not get all the residue out, and then the container is considered full and hazardous. So don't put this task off until later. Let's go through the process of triple rinsing. First, make sure the pesticide container is completely empty of pesticide concentrate. Sometimes the concentrate gets stuck in the handle or around the neck of the container. Next, fill the container about 20% full with water. Fasten the lid and shake the container for at least 30 seconds. This helps wash away any concentrate from the container into the water. Remove the lid and drain the rinsate into the spray tank. Repeat these steps 2 more times. You've now triple rinsed the pesticide container, and it can now be disposed of according to label directions and local and state regulations, or better yet, be a good steward and recycle it. Another way of cleaning rinsable containers is pressure rinsing. This method again gets the container sufficiently clean so it's not considered a hazardous waste. If you plan to use a pressure rinse device, consider using goggles in addition to your other mix and load PPE. The pressure can cause splashes. When mixing, drain the container as best as you can. There are several different pressure rinse devices on the market, even for large containers. For a 2.5-gallon container, puncture the bottom side of the container and rinse the container for 30 seconds or until rinsate is clear. Rinse into the spray tank. Don't forget to carefully rinse the cap with a slower stream of water. All this rinsing should be done over the spray tank to capture the rinsate. The cap can be discarded in your normal trash, and the container can be collected for recycling or taken for disposal. Not every container is rinsable. For non-rinsable containers, empty them out as best as possible. Slit the side seams of bags. Take returnable containers back to the manufacturer or dealer. If they're not recyclable or returnable, dispose of the containers with the normal refuse. Don't forget to make the container unusable by puncturing holes in it or cutting the container in half. Plastic pesticide containers can be recycled. In order for containers to be accepted for recycling, they must be clean and either triple or pressure rinsed. Stained containers are acceptable, but containers with pesticide residues are not, and dirty containers can jeopardize the recycling program. If plastic container recycling is not available, dispose of containers in the local landfill or incineration facility. To find a container recycling program, contact the Agricultural Container Recycling Council, ACRC. Where do recycled pesticide containers end up? They're made into bridge and marine pilings, fence posts, pallets, and field drain pipe. The first step for any pesticide application is to read the label and gather the necessary personal protective equipment for the application. Make sure your PPE fits and is in working order. For handheld or backpack sprayers, consider wearing equipment that protects you from contact with the equipment. Remember, you can always wear more PPE than the label directs. Try to avoid walking through the treated area during the application. If possible, apply the pesticide so you're backing out of the treated area. This helps minimize exposure. Also, consider wearing shin or knee-high protective footwear. You may even consider chemical-resistant PPE. The use of equipment such as mist blowers, air blast sprayers, and power dusters greatly increases the risk of potential exposure. Consider an enclosed cab. Otherwise, a chemical-resistant suit with a hood, gloves, footwear, eye protection, and a respirator are usually required with these types of applications to provide adequate protection. It might sound elementary, but be sure to clear all people, pets, toys, bikes, wagons, and any other items out of the application area. Even if the application is a very directed one, like a crack and crevice treatment, make sure people are removed from the application area during the application. Check the pesticide label for the REI, restricted entry interval, or any specific ventilation requirements if applications are made into enclosed spaces. You've spent all this time and energy getting you and your sprayer properly prepared for the application. Take the time to make sure the application hits the target. Okay, you're ready to go. Make sure you're applying the pesticide in an even and consistent manner. Look around when you're applying and make sure the application looks okay. Does everything seem to be exiting the sprayer correctly? If not, stop the application and take a look in the tank to make sure the spray mixture is thoroughly mixed. Don't forget about the application equipment. Check it often during the application to see that it's in working order and not leaking. Granule applications are supposed to be dry and not moist, clumpy masses. Be careful when you need to turn or pause your equipment. It's probably best to shut off the equipment in these areas so you don't over-apply in one area. Finally, when you're finished with the application, be certain that all post-application requirements are met. These may include requirements for soil incorporation, posting, restricted entry intervals, and grazing and pre-harvest intervals. Although you may be finished with the application, now you need to clean the application equipment. This should be done as soon as you finish the application. We've already discussed the proper way of cleaning pesticide containers because it should be done during the mixing process. To clean application equipment, consider what you will do with the rinse water. One option is to apply the rinseate to a labeled site, including the site you just made the application to. In order to rinse on site, carry rinse water with you. Add water to the tank and agitate it around to rinse the tank. Then apply that initial rinse water to your site of application or any other labeled site. This will not reduce your level of pest control and is very important in protecting your mixed load site from repeatedly receiving rinse waters. Once the tank is initially rinsed, you can decontaminate it back at the mixed load site. Another option is to collect the rinseate and use it as mix water in the subsequent spray batches. Make sure the collected rinseate is compatible with the other products that you might mix it with. You can imagine if you use a herbicide rinse water in an insecticide application. Oh boy! Also, it's not a good idea to reuse rinseate if it contains strong cleaning agents such as bleach or ammonia. Finally, if you couldn't apply the rinseate to a labeled site or can't use the rinseate for subsequent spray batches, it'll most likely need to be disposed of as hazardous waste. When product residues left in the tank pose concern for subsequent tank mixes, it's necessary to decontaminate the tank. If tank contamination is a major concern, labels have procedures listed for decontamination. Make sure you follow the label. As a basic rule, you can simply use a water detergent solution or use the label prescribed decontamination materials and circulate them through the entire system for 3 to 5 minutes. Afterwards, flush the entire system twice with clean water. Also clean nozzles and screens. Can you imagine explaining what happened in this photo? The application was an insecticide for soil insect pests, but the tank had residual herbicide that was not decontaminated. Well, it may have killed the insects by causing them to starve to death. And finally, don't forget about personal hygiene. Remove contaminated clothing and handle it cautiously until cleaned. Shower immediately following any application to reduce any further pesticide exposure. Wash contaminated clothing separately from any other household clothing. All heavily contaminated clothing should be disposed of as hazardous household waste. Plan your product usage as best as possible. Don't buy more product than you need for the season. Things change in life, and we know regulations change as well. Disposal of pesticides is an expensive proposition. They are typically considered hazardous waste materials, whether it's the unrinsed container, leftover spray, or product you can't use. To dispose of hazardous materials, you must pay someone to package it properly, pay a hazardous waste transporter, and a hazardous waste land burial or incineration facility to take the waste. So don't generate your own headache. A successful and safe pesticide application takes careful planning. This begins with reading and understanding the pesticide label. Many things that you need to safely apply a particular product is right there on the label, from what personal protective equipment to wear, the correct application rate and method, when people can safely re-enter the treated area, to storage and disposal of pesticide containers and pesticides. Every application should begin and end with a complete reading of the pesticide label. Question 1. When mixing two products together in a spray tank, what can cause incompatibility? 1. pH of water used in spray batch. 2. Air temperature and humidity. 3. Mixing wettable powders into the tank prior to adding ECs. 4. Conflicting chemical properties. A. 1 and 2 only. B. 1 and 3 only. C. 3 and 4 only. D. 1 and 4 only. Answer D. pH and chemical properties can cause chemical incompatibility. Question 2. How can you dispose of a plastic pesticide container that was not rinsed when it was emptied? A. Take to a local landfill or incinerator. B. Take to a plastic pesticide recycling program collection. C. Take to a local plastic recycling program collection. D. Pay a hazardous waste transporter to package and transport it, and someone else to accept it at a hazardous waste facility. Answer D. If a rinsable container is not triple or pressure rinsed, it is considered a full container and usually requires disposal at a hazardous waste facility. Question 3. When is a person at greatest risk in regards to handling pesticides? A. When applying fine dusts. B. When applying small driftable droplets. C. When re-entering a treated area. D. When mixing and loading product concentrates. Answer D. Mixing and loading is usually the most hazardous, since you are exposed to the highest concentrations and you are handling them in close proximity to your eyes, mouth, and skin. This presentation was authored by Becky Hines, Carol Ramsey, Carrie Foss, and Brett Johnson of Washington State University Urban IPM and Pesticide Safety Education. In addition to sources noted on the image, graphics were provided by the following sources: Nevada Department of Agriculture, University of Missouri, Virginia Tech, and Washington State University. The presentation material was reviewed by Beth Long, University of Tennessee, Ed Crow, Maryland Department of Agriculture, Jean Kasai, U.S. EPA, and Susan Whitney King, University of Delaware. Narration was provided by Drex Rhodes, Washington State University Information Department.